What's computer vision? Um, Computer vision for me is making sense of pixels. I think computer vision has a profound effect in the way that we understand the world, because as humans, vision is so centric, right? If dogs will be making computers, maybe they wouldn't talk that much about vision. But for us, it's so centric in the way that we perceive the world and the way we learn about the world that actually I think it's easier for that, of course, to program and think useful ways machines could get information, through vision. And also especially because vision is one of the much more complex senses that we have,
Image and videos represent nowadays the 80% of the data that we produce, and the introduction of computer vision and machine learning becomes necessary to start extrapolating information out of this new source of data.
Okay, so perhaps you could introduce your...
First, just a point of clarification, because we often talk about AI, and so just to be a bit more precise about what we do in Romy, because AI is quite a vague term, and so what we do mainly is robotics and computer vision.
Computer vision is at the end a limited set of tools and systems that are basically based on mathematical representation and description of the pixels that represent the image, that are part of the image. And machine learning is based on a different approach of interpretation of those pixels.
So the rover is for weeding, and to remove the weeds, you need to detect the weeds first. And so we use computer vision algorithm to detect where are the weeds, where are the salads.
So let's see one by one which are the methods that we implemented in our algorithm, in our system. So we start with the feature extraction. In order to do that, in fact, we go one by one over the images and we understand which are the pixels in common between one and the other. From this method, in fact, it's possible to recreate an orthomosaic view, an orthomosaic image. But afterwards, we need to align it to all the previous images that we've been creating in the previous analysis. So after the generation of the orthomosaic view, what we do is that we start to cut the main image into a portion, into a series of smaller portions. This facilitates the execution of the machine learning algorithm and the possibility to recognize the presence or not of lettuce in the scene. After the recognition has been performed, we put together the images once again, and we can reconstruct an orthomosaic view with the detected position of the different lettuce. This is necessary to understand not only the position, but also the area of growth that these different lettuce are occupying over time. From the geolocation of every single plant, we start to analyze the growing curve over time. This is possible thanks to the implementation of MaskRCNN, so thanks to the generation of all these different areas that during time will tell us the growing pattern of every single lettuce. And this will be extremely useful to understand when is the moment to harvest the plant, when the plant is in fact bolting. More or less it is, okay.
So we do, what I showed was about 2D computer vision, but we do a lot of 3D computer vision also in the project. And so let me show you a bit what we do with a plant scanner. So it is used by biologists to study the geometry of the plants. So they want to reconstruct the 3D architecture of the plant and study that architecture. So for this, we take many images of the plant by turning a camera in a circle around the plant. We generate a mask, by again a segmentation algorithm to detect where the plant is and where the background is. And then we can generate a point cloud by an algorithm called space carving, or shape from silhouette, which based on the many silhouettes you collected, it carves the space for the shape which is most compatible with all the projection of the shape.
So what we do in roaming at the end, no, I would say in a way we hack existing technologies. We take advantage of the low-cost cameras that exist in phones, right? We don't need to rely anymore in high-end industrial cameras. We take advantage of the low-cost computational power. Computing is cheaper than ever. So these images that we take, we can process them with software in ways that wasn't possible before. We take advantage of software, and especially of open source software and free software. Then we build the training models, right? So this software is capable to detect on top of that images, insights, to go from data to information.